everybody, welcome back to another episode of FTB Infinity Evolved. My name is Brink, and we talked about getting a shack together, a little house for this episode. I already built something close to what I want to do. It'll change up a little bit as we go, but I do like the Polynesian roof. I think this is called a Polynesian roof, this design. Let's take a look real quick here. You see how it skips every other one. It goes higher and higher. So there's a sort of slope that goes out like that. So, yeah, this is close to a design that I need for the type of power we're going to work on in this episode. We talked about power in the last episode. We are on episode 3 after all. What are we dilly-dallying for? Just kidding. We are a little bit going fast because we're establishing power in this episode. And I think that's pretty good. I mean, I could go for a basic and smaller startup power and sort of match where we should be. But I think we're able to, with the resources that I've gathered, mining for a few hours, the thing that I can build as far as power might as well go a little bit higher than, we can't go full reactor power, but we can go a little bit higher than what we probably should for this episode. So what I was thinking of in immersive engineering, which I haven't touched a whole lot, that's what I'd like to maybe do. And you guys suggested I go with immersive engineering. Oh, and by the way, I wanted to mention, you guys gave me 100 likes. That's amazing. That's amazeballs. So what I wanted to ask, if it's possible, let's see if we can get 110 for this episode. I don't know if that's possible, but we can give it a try. But thank you so much for all those likes. I really appreciate it. Anyway, guys, we want to set up some power, and there's 3 basic designs for power in immersive engineering, which I wanted to tackle. I want to go with immersive engineering because I really haven't touched it a whole lot. One of them is called the, what's it called? The thermal. Let's pull up immersive engineering by the pack, and then we can take a look. Immersive engineering. So, external heater is not the one. Thermoelectric generator, this is the guy. As long as you put 2 opposite temperature, basic temperature or natural temperature items in liquid form, I think it has to be. I don't think it could be a block form. Oh, actually it can be in block form. The block of ice will work, packed ice. As long as you put them on the side of this device, it'll create energy from the difference of the temperatures. And there's a lot of blocks and liquids that have a basic natural temperature. For example, liquid pyrotheum, blazing pyrotheum, and lava. All of these liquids are very hot and they have a basic natural Minecraft temperature. Water and gelid cryotheum, they have a basic natural cold temperature. So depending on which ones you use for this generator, you'll produce a certain amount of power output. So let's say you put lava and water opposite corners on this thing. It'll produce a certain amount of power. But if you use lava and ice, that'll produce a different power than what you did with the water. And by the way, you have 4 corners, so you can double it. You can put lava here and lava here, water here and water here, or even a mixture, water, ice, lava, pyrotheum. You can mix it up as much as you want. The thing is that you have to take care of what kind of liquid you're going to use, and that'll depend on how much power you put out and how many sides you put. So you can make a lot of these. You can make like 4 or 5 of these and just fill it up with lava and water all around. So that's pretty good, but it produces a very little amount of power. And I think I want to go with a little bit more. And so there's something else called a windmill. Now, a windmill produces a lot of power if we had a base up top, up on a cliff somewhere. Because a windmill, as you know, is dependent upon elevation. So the higher you go up in the sky, the more power you put out. We are here on level 64, so we're not going to produce a whole lot with a windmill, unfortunately. So we're not going to go with a windmill, and I'm not going to build a tower with a windmill with a lot of wires coming down to feed my base. That's just too much. So what I think I want to do is go with a different kind of immersive engineering power. And I don't know if this is the only 3 powers that there are, but the third one that I found is a water mill. And a lot of you guys suggested it. And so I want to go with your suggestion. And we have water here, but we can put really a river anywhere we want. And I can even put a fountain to feed the watermill above. And so that's why the design of this shack or barn or house, whatever you want to call it, is in this shape. It sort of looks like a farmland house, like a ranch house, or I don't know what you call it, but it looks like it's ready to have a watermill attached to it. So I kind of thought in the side here, but I think it may work out better if we put the watermill back here, and then we can run the wires to go into the base and then feed our machines. And hopefully by the end of this episode, we will get to some machines. I did a lot of work inside also. I worked on the drying racks and getting some food together with rotten flesh because I've been caving a whole lot. I've been caving for a couple of hours to get enough resources and metals and smelt them down for this episode. So, killing a lot of zombies down there in the caves. I got a lot of flesh. I went to kill some cows right now to build this glider and feed them and all of that. And so we'll put some more up there in a second. But I want to get right to it. So let's get started. The first thing we want to build is something by immersive engineering called the kinetic dynamo. Kinetic dynamo is what I'm looking for. And this is the guy. Typically, immersive engineering uses this kind of color or texture, gray with brown. So if you see something like that in your NEI, most likely it's immersive engineering. It's a quick way to find it. So let's take a look at what it needs. We need iron, steel, and redstone. Let's get those right away. And I love this setup because you can sort of see everything you need. And I'm going to change things up, so don't think these things are going to be here. I thought I would need them, but I think I can reach just fine from down here. So I'm going to remove these in a second, but let's just get to building this. Now we're going to need some redstone as well. Let's put these in here. You know what? We can put them in this side drawer and have them ready for when we need them. Now let's take a look at these two blocks here. We're going to need more iron, that's fine. Electrum, I'm going to have to smelt for alloy. It's a combination of two metals, and I don't remember what they are. Gold and silver. Fine, we'll do that. I'll have to go to the smeltery to do that. I don't have any machines yet to do it. We need lead, we have the redstone, we need some treated wood planks. So, treated wood planks, fine. Lead. By the way, I went to the nether with the guys. We all went together, and I got some cobalt and some ardite. Awesome. Now, is this lead? No, this is thaumium. Yes, yes, yes. I got to get used to this texture pack again. It's been a while. So, lead is usually a dark blue color is what I'm looking for. Actually, no. I think there's a couple of kinds of lead, and this might be it. Let's take a look. It is. So I got to kind of remember that. If I smelt it in a Tinker Smeltery, it's going to look like this. If I smelt it in a different kind of machine, it's going to look like that. It's going to look like this or that. I don't know. So we'll have to keep that in mind. Now, the electrum I'm going to have to do off camera. We're going to get some gold and some silver. And I think this is silver here. Let's take a look. Yes. Let me make some electrum in a smeltery. I'll bring you right back. Alright, with the electrum we are going to make, I think before we do any of this we're going to need to do this because we only have one crafting table. So let's go with the top one at least. And let's see what we have. I guess we don't have anything. We have the electrum, treated wood planks with a redstone block. That we can do. I don't think we need a colored redstone block, so let's just grab one of these. I think that'll work. So, that, we need the lead, and I don't see the lead here. Did I not grab lead? Yes, I did. Okay, so it goes like this. And then what was the rest? Electrum on the sides, iron across the top. Let's pull the iron on the top with the... Oh, that's why it was in the case. As long as it's here, it's not going to go or occupy. So, I think it was steel. Oh, no, it was electrum that goes on the sides here. And that's the MV capacitor that we needed for the top. Now we need this here, which requires these coils. And we're going to need these treated sticks. Now, there were 8 around divided by 2, so that's 4. That should do. And let's see if we can pull it up now. Yeah, there it goes. Now we can do the rest. So we have the kinetic dynamo, and this is where we connect the watermill to. Let's see how to build a watermill now. And this is the big part. Water wheel, I think it's called. Yeah. So we're going to have to dive into the making of this, which is a few steps. Let's see what they entail. I think we're going to need some more treated sticks, though, and some treated planks as well. And to make them, I think it was 8 around a creosote bottle. So let's make them all. Here we go. Coolidge. We'll do that. And we need more sticks, though. So let's pull up the sticks as well. We'll make a few. And, oh, you know, how many do we need of this? This is 8. So we're going to need 8 times these things. And we have an extra here. So that's 2. We're going to need a lot more sticks. Okay, so let's pull up the wood here. We can use the oak. We got a lot of oak. And we'll convert them all into planks, because we don't get a lot in this pack for planks. So let's convert all of this. Bam. All right, so let's convert more sticks, and I think that should be good enough. We may need it for some future for other things. We have 2, and I believe we needed 8, so we need 6 more. So we can do all 4 of these, and we need a little bit more still. So let's see if this will do. And 8. Awesome. Now we need this thing in the middle, a shaft, an iron shaft. Oh, don't tell me we need a metal former. We may need to set up a basic power in order to run a metal former. So let's see what it takes to make a metal former. So is this the only way to make it? I guess so, because it only pulled up one recipe. There's no arrows to go on. Metal former. So, oh boy. Oh boy. Okay. Oh, this is easy. This is with the hammer. We can use the hammer for this. We just need to hammer up some copper. And how many were there? These make that. And so we need 5 of them. So we're going to need 5 of these. That's 10, because the hammer reduces by 2. So let's grab some copper. And we can do this in our inventory. What is it? It was 10, I think we said. So we'll do that. And I think we can pound this to make 5. Oh, we actually made 10. Okay, we made a little bit more than we needed, but we'll use it in some future, I'm sure. Actually, no, because we need 2 of them, 2 sets, so it worked out. Now we need 2 chesses. Let's see if we have any before we build any more. It doesn't look like we do. We can go ahead and break up some of these woods and make 2 of them, and that should do. Alright, let's see if we can make these, what are they called? Toolkits? Toolbox. So, a chest in the top. Oh, these are bronze. I made a mistake then. How do you make bronze? Actually, no, I have bronze. I remember. I accidentally joined copper with tin, I believe it was. So I think this looks like, I don't know how to tell the difference between the two, but let's pull this. Yep, we got the right one. So we'll do that again. It's 10. It worked out the last time, so let's put 10 in here. 1, 2, 3, 4, 5, and 10. So we'll smash this up, and now let's give it a try. Go around into the chests, and we have the toolboxes. They don't stack. That's fine. We'll need this, oh, iron chipset. Are you kidding me? We need the basic power then, guys. It looks like we do. We got to build an assembly table. Well, let's change our plans. We could go for a dynamo or hobbyist engine. One of these guys. Not too difficult to do. Gold into these gears. Can do. Simple pistons and glass with gold. So let's see if we can do that. We're going down the rabbit hole, guys. We've been here before. Alright guys, just doing a lot of stuff off camera. Let's see if we can get some obsidian. We have to make some obsidian now. And I don't remember how this goes. I think it goes, let's see. I think I have to get the lava into this area. I wonder if I can just smackety smack this in here. Doesn't look like it accepts. So it might be in one of these drains, maybe above the drain. Let's take a look. Boom. Doesn't look like it's draining. So it might not be that. Okay, I think I got it. We're going to place the drain down in any direction. Actually, you know what? I can get rid of this. Let's place the drain down here, and then we'll place the lava right above the drain. Maybe it'll take an input from the top. Let's see if that'll work. And we'll turn it to go in. It doesn't seem like it's draining though. Oh, I didn't put the controller in. I don't think it's going to drain unless I put the controller in. There it goes. So it worked. Now, how much of the lava did it pull? All of it. Great. You know what? I have an extra lava, and maybe I'll save that. I'll keep it in the tank when I finish using the tank. But now we got to get this water in there, so I think hopefully this won't break and fall inside. Let's see if I can grab it by jumping here and sort of doing that as I walk forward. Could have fallen into lava there, guys. Let's put this water on top and drain that. Hopefully it's the equal amount on both. And it looks like it is. We're ready to go ahead and start pouring. Let's take a look. Let's pour one of these obsidian and see how many it'll take. I think it's 8 here. 14. Oh, great. We do have enough obsidian. So yeah, easy way to make obsidian. I think we have enough. Well, this has proven to be one of the biggest rabbit holes I've ever been in, guys. This takes a lot of work. This goes up here, and we have a thermionic fabricator. I didn't mention it because I just found out we need to build one of these, and it needs power. So we got to build something to feed it power. And I'm thinking what's it called? The old hobbyist engine. I think there was something that was holding me up from building this. No, it looks like we can build it. Let's build one. And I'm thinking we can probably point it toward there. Yep, it works. Alright, so we'll need some water and some coal. Charcoal will do. We'll just smack this in here and let it wait for us while we get the water. I'm going to need the tanks. And let's see, where did I put the tanks? I'm going to get a few tanks, just a couple of tanks. Make sure that this hobbyist engine is always full because we need to have it filled with water. Now, where is the bucket? I don't see my bucket. Did I leave it in the smeltery? Oh, here it is. It's with lava. Alright, so I'm wondering whether I can use lava also. It looks like it does take. So, I may use up this lava, but I need the bucket for now. So what I'm going to do is, before laying down the thermionic fabricator, this has a buffer of power. Let's see which one it is. RF, right here. And this is the temperature. Okay, so what I'm going to do is fill this up with a buffer of power, and then I'll connect the thermionic fabricator. Because even when it's not processing or doing anything, it uses power, so it's a waste. So what I want to do is build up the reservoir of power on this battery, the battery inside of this hobbyist engine, and then I'll lay it down and put the ingredients in and have the ingredients ready so that I can pop it in real quick while it's producing even more power after that. Alright guys, I'll bring it back once I have some energy developed. Alright, this looks like it's working itself up to 100 RF, so I pulled you back just to show you what I've done here. I've set up a hobbyist steam engine with a lever and water above feeding downward, put in a couple of coal coke, and It's heated up all the way to max, but it's floating on steam, so it's doing well. I have no danger. It looks like it's going a little bit over now, but it's going down in power, so let's go ahead and get started. I put the pattern in just to keep it there. It does remember the pattern, but I do have to supply the material that it needs, so let's put it in here. I don't think we want to put more than 2, though, just so it doesn't make too many. Let's put the sand in. It goes up here, and it should melt this to glass. I don't see it working, though. So, oh, actually, no, it goes here. And a pattern goes there. I think that's the way it goes. Let's see if it's working, though. Doesn't seem to be. And this machine requires RF power to work. There is no power. Oh, well, that's an issue. All right. Hopefully, no, it doesn't keep the power, though. So that is an issue. I'm going to have to make some wires that'll connect from this over to the thermionic fabricator. Let's put it a little bit further. And let's set up the wires. Okay, so let's just kill this so it doesn't waste too much of this coal coke. And unfortunately, I thought this would have a battery buffer inside, but spending time idle, it just vanishes. So that is a problem. Let's build some wires that'll connect, the conduit type of thing. It's LV connectors. LV wire connectors is what it's called. We're going to need some hardened clay. And I have some clay ready for us up here. Here we go. And we're going to need, I think it's 2, but let's make a few. And we'll cook these up. In fact, I think I'm going to cook some more. Have it ready for some more that we will need very soon. Yeah, that should be good. We'll cook this up. I need hardened clay. Yep, there you go. Okay, so we'll put this away. Let me bring it back once I'm closer. Alright, we can grab our 4. Let's see what we'll need. Some copper down the line. Let's put this down here. I think it was on the corners, and copper down the line. Is that the way? Yes, and we have 8. So I don't think we'll need more than that for now. We do have more clay cooking, so we can do more of them later. But I'm just trying to connect this. And so we will connect one that goes from the output of this hobbyist engine over to here, and hopefully it'll take an input from the side. I don't know if it requires from the bottom or something like that. And now we need some wire. So I think this is the wire, LV wire coil. Yeah, that's exactly it. We'll need some treated wood, and I don't see any. Let's grab 4. Okay. And it didn't pull up. I think I hit shift instead. But this should be enough. So what we'll do is right click the mouse and stretch a wire across. That's nice. This is one of the nicest designed conduits there is. This is low power though. It can only handle about 2 meg RF. Or no, I'm sorry, 2000 RF. Yeah, 2000 is what it is. The next tier, the MV wire, can handle a little bit more. I think 2000 to 8000 is what is acceptable for it, and it has less loss. The only problem is it costs more. So this cheap wire costs less to make, and it can handle the power that we need for this. We don't want to pull all the power too quickly because this takes some time to work. So the pattern is still in here, but I still do have to put these in here. And before I connect these, in fact, just remembered, I don't want them connected. Let's break it. And we have to bring up the power again on this. Let's go ahead and bring it up. This is overheated. You know what? I think we have to pull this out. And I think we have to let this cool down, because apparently the water is not cooling it off well enough. So let this... You know what? I'm going to bring you back. I'm going to recharge the buffer again, and then we'll connect the wires and see how it goes. We're getting close, so I brought you back. I made an LV capacitor. This will prevent the energy that we're wasting to collect, because it does go up, but it vanishes while it's going up, some of the energy. So what I'm doing is trying to feed it as quickly as I can to the LV capacitor, and you can see on Wayla that is going up pretty good. We have a good amount already. I think we got more than this maxes out. Actually, no, it maxes out at 100. So it's got about 50 to go still. So what I'm going to do is probably use up this as well as this. And we're going to go ahead and start. So I'm going to place the diamonds into here with the sand pattern there. It looks like it takes, I don't know what this thing is. I can't drag it or anything like that. I've never used one of these thermionic fabricators. So we're going to need the diamonds, the redstone. We're going to need 2 redstone. And I'm only going to give it what I think it needs. It needs 3, 4, 5. So 1, 2, 3, 4, 5. And there should be no error in doing it this way. Let's see. So no power. Yes, we haven't supplied any power yet. So let's go ahead and see if we can connect this. Now, once I connect this, it shouldn't power because I think I have to use the hammer. And this hammer I used to set it as an input here. The Wayla showed 0 power until I hit it with a hammer to let it know it's connected. Then it started rising up. So let's just take a quick look again here. It looks like it's holding up just fine. Looks like it could continue, as a matter of fact. But yeah, so this is at 75,000, and I think we can go ahead and start. I'm just worried that I might have to redo this all over again. But let's see if this goes. Now, did this start? Oh, I have to hit it with a hammer, it looks like. So let's do it. There it goes. And is this going? Still not going. So what is it? And the Wayla doesn't show that it's operating. The energy is not coming through here. So it must be the orange. Oh, simple thing. Let's do that. Now this should be, oh, there it goes. Okay, Wayla shows that it's working, and it is. How fast is this draining? It's holding up. It's actually draining kind of slow. I think this was filling quite faster. This is making sounds now. I'm worried about it. Oh, let's get rid of that. I hope I don't break this thing. Let's switch to sword. How about empty hand here? So we have 65,000. It is holding up, and remember, it is feeding at the same time. But this has a bottleneck. I think it can handle the bottleneck, though. And it is going up, and we have it. We're completely done. We don't need any more power here. So let's shut this off so that we don't waste it, because the power that's going into the thermionic fabricator is just going into the air. Yeah, it's just draining. You see, I'm not even using it for anything, and it's just draining. So we'll keep the rest of this cold coke power into here. It'll use up whatever's left in this flame here, and I'll keep this. Let's just drop it on the floor for now. I don't have any space. It'll continue, and we'll just load this capacitor up. Cool. All right, so we need a diamond gear, and that goes down here to make the assembly table. And to feed the assembly table, we need a laser. And now we're going to need one of these with the wires again. Now, where's my wires? Do I have it on me? I don't see any wires on me. I wonder if they just vanish once you use them and you break it. No, I have one. Yeah, I guess they're vanishing, or they remain here, actually. No, they just remain. All right, so we can feed right off of here. We don't have to move anything there. And we can feed a laser. And the laser, I'm going to try to point it this way, but I don't know if it can manually point. No, apparently not. So let's break this, and let's see if we can point it at a block, and hopefully it'll take. We'll just place the block somewhere on line with this, and place the laser across to it. Apparently that's the way it goes. Okay, so we're going to have to place this cobblestone somewhere around here, and we'll place it there. Alright, so let's get rid of this, and now we can place the connector right there and the wire to it. It goes there to there. That's a pretty straight line. It's not going to remain here. I mean, I'm going to move some stuff around. I mean, the assembly table, I don't believe, but I'm not sure, I don't believe is something that we're going to use a whole lot. We can place it right in smack dab in the middle of the room. By the way, this room is even number. First time I'm building even number houses. For a certain reason I want to get into in a future in a buildy episode. So here we will need to figure out how to do what we're doing, which is a long way away from what I even remember we were doing. Water wheel. There was something with the water wheel that we needed. Did we finish all these crafts? We did. So why can't we just build... Oh, we have this. There is something else. Water mill, maybe? Let's see. We are on page 1 of 1. I want the circular thing. Here it is. What's it called? Water space wheel. Okay. So we will need a metal former. And that's why we were making the assembly table. Let's try to find out why. Metal former. Maybe because of this iron block here. Yes. Iron and redstone. And I am sure that's going to take a while to do. So I'm going to have to go off camera again. Because I refuse to make you guys wait. I want this to be a fun episode for you. I'm going to make 4. Just to keep it in here. Hopefully it doesn't waste too much of the energy. Just remembered. I'm going to have to reverse the power to output this way. And we do have a little bit of a buffer still going down. Maybe I could use up that before it goes away. So 1, 2, 3, 4. And we have to pick one of these now. Yes, I've used the assembly table before in a long time ago. I don't remember where. I think it was Direwolf. So it's the white centered one. Alright, let's pick that one. And so this will start working. The thing is, the energy is so low that it will take a long time to register. I don't even know if this is enough. Is it taking? No, it's not taking. Okay, so we're going to have to set the hammer into place. I'm going to have to take a look at this. Can I reverse this and see if it'll feed here? There it goes. So this isn't feeding enough, or maybe it was only feeding out there. That's probably what it was. The power was draining into here, but I reversed it. So now both powers should be feeding here instead. Yeah, this is going to take a real long time. I'm going to cook up the 4. Maybe I'll just cook up the 1 and then I'll bring you back and I'll leave the 3 while we do other stuff. Alright guys, it just finished and here it is. So, I'm going to let this guy keep going and feed this because since it just finished, you know what, we should disconnect this because this is gaining power. So let's just let this capacitor build up the power. We're going to need the power from this to feed our metal former. Yeah, what we're going to do is put maybe the metal former right here. You know what? Maybe not, because with IC2 you have a chance of breaking it if you use anything but the IC2 wrench, which is something we should probably build just to make sure that we get our stuff back. Now this doesn't even guarantee 100%. It's more like 90%. It guarantees giving you back your metal former. This is 100%. This flux omni wrench, but I can't afford it right now. There is also the Yetta wrench, but we definitely can't do this. This is probably too expensive. An arc furnace, an alloy smelter, which we are far from being able to do. I love this pack. I love the way it's so... it requires you to keep going in... you can't really go too fast. You gotta go slow. I love this. Anyway, smart wrench. This is something I think may work. But I am going to make the IC2 wrench instead, just to make sure. Anyway, I think what I'm going to do is place it down here, just to be on a safe side. What we're going to do, we're going to go down a chain here. I got these things ready. We can go ahead and build the basic machine casing, and that goes with the electronic circuit into, well, we're going to need 3 of these. It goes into this pattern, which is down here. I believe that's there in this. Yes, metal former. Awesome. Made some more wires also. And we will place it, if I put it here, it's not going to have a whole lot of space. Maybe I could put it right here and put another terminal there. Meat. Put that there. Let's put it there. This way we don't have to take a chance of breaking anything and not getting our stuff back. That'll do just fine. Let's put it here. This should be charging up already. Let's see. We should see a little bit of red up here. Oh, I have to put it on output here. Forgot about that. Let's do it in the other side, in this side here. I should have enough to go from here to here. Let's get the wire down. And that should be powering up. It is already powered. We need this on extruding. There. We need a block of iron. And give me that block. Here we go. Stick it in there. And we should have that shaft. And then we'll be able to build the water wheel. Now, while I was waiting for this slow Mamma Jamma to go, it was so slow, I dug up a little bit on the outside. So this will keep recharged, and the LV capacitor should increase because this doesn't vanish. The energy that goes into the metal former, it remains in a buffer. So that's cool. Oh, what are we doing? We don't go out here with a shaft. We have to build the water wheel now. So I believe it's this around that, and that should be good. We have the kinetic dynamo. We're going to need a couple of blocks to build up with. Let's get some dirt. And yeah, let's go right out here. It'll probably be faster to come out through here. And we got to measure the size here because I don't know if this is going to work for us. Let's see if we can build upward. Where's my dirt? My dirt. I think it's about 4 blocks. Why don't we build it closer to this side rather than this side, since we have even numbers here. Let's place it like that. And the LV capacitor, or the kinetic dynamo, is that the right direction? Maybe. We will find out. I just want to measure the size. We can always break this apart. This is 1 block too high. I want this to be buried underneath the... what do they call that when you're in the war? A foxhole, I guess it's called. Okay. So there, and then tinier. This will do. And smallest. Okay. So this is what we needed. We can place these around in the corners. Ooh, too big. We need them smaller. So let's try that again. With a saw, we'll take them, make them tiny, super tiny. Let's just shift click them in. And now we should be able to cover this up real nice. Yeah, now it doesn't show. I think that'll work. Yeah, we're all covered here. Okay, so we're good. I may add a pinstripe not only to the bottom like I did here, but also to the top. That might be something. Let's make our way up to the top of this, and we can start running the water after we've cleared the canal. The way I built the canal was by putting blocks where I needed them first, and I made sure not to go more than 7 blocks or 8 blocks because I need the water to be able to flow all the way through. And so we're going to break this part off. I just need it to start rolling in this direction, and then we'll break it off, and it should continue as long as there's water on top. I'll explain that in a moment why I'm doing that. But let's make our way up here and see how far we can get up here to lay the water down. And hopefully I have a bucket. I do. And let's see if we can go here. Will it go in the canal? It will, yes. Yeah, I can trim this up and make the water flow toward a river over here, and that wouldn't be a problem. But we are generating power here, guys. It is generating power. Now, what I wanted to explain with this, it turns out, oh, we're just 1 short. You know what? It doesn't matter. Yeah, because I'm getting rid of that. So, I went 7. Okay, let's go up there. And we were going to break it anyway, and I'll explain why. Right now, the way it's flowing, if you get water, well, if you get the water mill to turn, it will produce 30 RF per tick. If it can flow from 1 block behind, it'll add 3, so 33 RF per tick. If I build 2 more water mills side by side, so there's 3 water mills running side by side here, it's 100 RF per tick. Instead, if I don't break this off, then it'll only be 90 because we're adding 3 to each one. So that's the reason for that. I hope that made sense. And that's a little trick you guys can use to get more power out of your watermill. Now, we need to make our way down. Let's clean all of this up. Alright, this should do it. And we're just about finished. I just wanted to cover this up, make it look nice. Alright, so let's take a look at what we have. Let's go back here a bit. Now, these posts are holding up the canal, and actually I have to build up one more here. I forgot. Let's see if we can aim correct. Yeah, that'll work. Okay, so the reason I'm putting this is not really to, carry the canal. As you know, gravity doesn't really exist here, partially. The reason is because I need something to hold back the water. So I needed this post here. And the post looks kind of flimsy, and it's not even supporting anything up here. So I sort of made it to look like this is just a decoration. And I needed to put it on this side since I have it on that side. But then these thicker posts is what's holding up the canal, or so it looks like. And so there's little things that are hardly noticeable that are holding the water back from, split splashing all around. If I get rid of this, it'll flow back here again. I've already tried. I'm not putting this down for any other reason than to make it look nice. The water does flow perfectly in the grass without it. I just wanted to make it look nice, and I think it looks better with the spruce flooring underneath. Looks a little bit more organized, I think. So I tamed up the water to make it flow only down here. I do have to get rid of some of this dirt and trim it up. I'm going to do that off camera though. But I think it's a working system. Now, the final thing we have to do to make sure that this works is to set up the power. Alright guys, I think I found the issue. I went up to the top of the kinetic dynamo, and it turns out there is an output. You have to connect it from the top. And it received power as soon as I put it on. So let's go ahead and wire it up and see, because I connected it over to the thermionic fabricator just to test it out. And let's wire this up, and this is still 0 of 256, but that's okay. That might be because the thermionic fabricator is pulling out more power than it can store. Yes, we are getting power. Awesome. Alright guys, I think we've run long, very long. This was a very long episode, not for you, but for me. This took a long time to do. Guys, I hope you enjoyed this episode. If you did, hit the like button, and I will catch you all next time.